Okay, right now, the only way we can solve, I'm going to go right to example 3, but I'm going to work my way back. So, if you're given this as a situation, actually, you know what? Let me do a smaller one to make it make more sense. If I'm given all right. So if I'm given this as an equation, then I have to solve for x here. So I got 4 to the x equals 64. Okay. It's not exactly the ideal question, but it'll work anyways. So right now, how would you solve this question? Well, you have to get both sides, the left and the right, so that they have the common base. You don't know how to solve it any other way. So is there a way I can make 64 4 to the power of something? What is it?
4 to the power of 4. 3.
Not quite. 4 to the power of 3. Therefore, what does x equal in this question?
3.
X equals 3. I didn't intend on doing it this way, but so I'm going to show you what my intentions were. Let's say hypothetically that we forgot that 4 goes into 64 3 times. Or 4 times 4 times 4 equals 64. So what I would do is I would change this. I would change this to 2 to the power of 2 to the x. And then this would be 2 to the power of 6. Okay? What I'm saying is I need a common base. So that's what you're working through today. And if you can't get a common base, then we have to go to our graphing calculator to solve it. So right now, if I have a common base, that means I have 2 to the 2x equals 2 to the 6. Therefore, 2x equals 6, x is equal to 3. That was my intention there. Just to prove to you that what you need to have is a common base in order to solve this. Okay? So the first part of this is just, okay, can you reduce these as powers of? It says reduce each of these to a power of 2. So what is 32 to the power of 2? 2 to the power of, what is it? 5. Okay? So I've got 16 cubed. So that's 2 to the power of 4 cubed, which gives me 2 to the power of 12. Power to a power, you multiply the exponents. Okay? What about the cube root of 16? How do I write cube root as an exponent? 1 over 3. So that gives me 2 to the power of 4 to the 1 over 3, which is what?
2 to the 4.
That's right. 2 to the 4 thirds. Okay. So the first part is just practice. So I've got 1/64 to the power of a third. So I'm going to change that to 64 to the -1 to the 1/3. Just moving it up. 64 is 2 to the power of what? Okay, -6 times a third is -2. So that would be 2 to the -2. Okay, fairly easy to begin with. Now we want to actually solve. So I've got 10. Again, what my goal is to get to the same exponent. So I've got 1,000 to the x minus 4. All right. Can I change 1,000 to the base 10? What is it? 10 to the power of 3. The x minus 4. So now that I have the bases that are the same, what does that mean the exponents have to be? They have to be the same or equal, correct? So I've got x plus 4 is equal to 3 times x minus 4. x plus 4 equals 3x minus 12. 16 is equal to 2x. X is equal to 8. Okay? I'm going to go through this quick. We've done this already. 25 to the 2x equals 125 to the x minus 1. So what's the common base between 25 and 125? 5. This is 5 squared to the 2x. This is 5 to the power of what? 3, the x minus 1. 2x equals 3x minus 3. Add 3, subtract 2x, x is equal to. Alright, so your first objective here is to see if you can get a common base. If you get a common base, once the bases are the same, then the exponents have to also be equal in order for the left side and the right side to equal, right? Okay? But what happens if I have this? And 3,579 cannot be put as a base value for it. Base value to 7. So if I can't solve it that way, the only thing that you can do right now is use your calculator. Okay, that's the only thing you can do. So what you're going to do is graph y1 is equal to 7 to the power of x. y2 is equal to 3,579. And you need to find the intersection point of those two. So it looks like that's your solution. Okay? I don't think I need to go through the calculator work with you. Just change your window, you get it to work, okay?
Do we use the Zoom stat for this? Or,
When do you use Zoom Stat?
oh, for the points, do we use Zoom Fit for this one or Zoom Trig?
You can. Is there a trig function with this?
No.
So then what do you use?
Zoom Fit.
Zoom Fit. Okay, but you also know something, Lexi. You should be able to figure out your window. It's an exponential function. Okay? So, and your y value has to go to 3,579. So you want to make sure your window has a maximum of a fairly large number, like 5,000. Right? So, Zoom Fit will work. It should show you both. And you find the intersection point. However, you can use your window with what you need to do. Okay? That's that. Right. I want to look at yesterday. A, B, X minus C plus B. Okay, so yesterday what we did is we looked at our transformations of a graph. Go to page 242. It says, describe the transformations of y equals 4 to the x caused by the following. So I have y is equal to negative 4, 1/3, x add 2, plus subtract 1. Okay. What's my a value? Minus 1. What does that do to my graph? Reflects it over the x-axis, that's right. Okay? You could also say that you multiply all your y values by -1, right? Okay, what's my b value? Big B? 1/3. And what does this do to the graph?
Horizontal factor.
Horizontal what?
Factor stretch.
Stretch by a factor of
3.
3. You're multiplying all your x values by 3, or dividing them by 1/3, right? What is my c value? -2. What does that do to it? Moves the whole graph left 2. And my d value, -1. What does that do to my graph? Down 1. What is the equation of my asymptote in this graph now?
Y equals -1.
Yes. Y equals -1. Because your whole graph moves down 1. Alright? That's the last thing that you do. So that your asymptote would move down 1. Okay? Alright. You looked a bit at the questions yesterday. Were there anything that you want to go through? Yeah, Jake.
Question 7, 246.
246?
Yeah. I just don't get how you get that equation.
Okay. Lindsay bought a classic car 15 years ago for $12,500. The car has tripled in value in that time. Write an exponential function that models the value v of Lindsay's car after t years. State the transformation represented by the function. Okay, so, alright, how do we want to approach this? Okay, so my standard would be this. Okay, a, b to the x, right? Okay, and I don't want to do that. Write an exponential function that models the value v of Lindsay's car after t years. So this is my v equals a b to the t. Okay? Now the car triples. So that's going to be that value right there. Okay? So what I want to find then is my original amount, which is going to be a in this case. Okay? So it's given us bought a classic car 15 years ago. Oh no, that is my A. 12,500 is my A. Okay? So I started at 12,500. So I want you to think of it like this. After the first year, how would I find out the value of the car?
It'd be 3 to the 115.
Yeah. I mean, just times it by 3, right? You're tripling the value.
Yeah.
After 2 years, it'd be 3 to the power of 2. 3 to the power of 3, 3 to the power, right?
Yeah.
So then, this is your equation right here. Okay, so the hard part of this,
But is it not t over 15?
sorry,
Is it not t over 15? Because it tripled in 15 years.
it tripled in 15 years? Yeah, absolutely right. Yes. So, yeah, I just didn't finish the question. After t years, the car has tripled in value in that time. Yes. So it's tripled 1/15 every year for 15 years. Okay? So the A is going to represent your initial value of anything. B represents the amount it's increasing by. Okay? And then T is just your X value for whatever it's given, in this case years. Does that make more sense now?
Yeah.
Okay. So if you're looking at 8 then, the population of a town is decreasing by 2% per year. The current population of the town is 11,568. Okay. So my population then, my current value is my initial amount, which is 11,568, right? Now how do I show something's decreasing by 2%?
Would you times it by 0.98?
Yeah, yes, you would. Okay, everybody hear that? All right, you're gonna decrease it, so you're gonna have 98% of what you had the year before, right? So I'm gonna times that by 0.98. And after T years. Is everybody following this? Pretty much? Okay, did you get done all the 171 already? Okay, so you could expect to be done, or at least through that review by Thursday next week then. Even though you're missing a class, you should be expected to finish this off. I may combine 7 and 8 for the test, because they kind of go with each other. So we'll be starting 8-1 on Thursday next week for sure. Okay? Any other questions today? Yeah, Jeffrey.
I did, on point one, I got it done, but how do you properly find the b, like it's just y equals b to the power of x?
Where are you at,
Like
Jeffrey?
on 234, like just
234?
from like looking at the graph.
Okay, so what do you, sketch the graph of each exponential function.
Number 3.
Sorry, 3. Okay. So you want to find out like what the
b value is.
well, are you on A or B?
I couldn't get b, I got A and C, but not b.
How did you get A?
Well, there's a grading on it, so then it said 10 squared equals 100, so then I just, I use all the y values on each of the graphs and then square rooted it.
Okay. Okay, so if your coordinate is 1 and 5, right? So your y value is 5 when your x value is 1.
Okay, so then you have to put it,
So you're looking at
500.
this, right? You follow that, Jeffrey?
You just put like the y value in?
Yeah.
Okay.
Yeah.
And that's what the answer is?
Yeah, because in the first one that you did, you put 100. So okay, let's try this a little different, Jeffrey. I'll start it from scratch here. So you got this, right? Okay, so in the first question, this is 100 when you got b to the 2.
Yeah, that kind of.
Right? Does that make sense there? Okay, so in the second question, you've got this. 5 is equal to b to the 1.
Why is it, oh, it's,
Because your x value is 1, your y value is 5.
okay,
Make sense?
yeah.
So then what, your b then is equal to 5. Does that make more sense?
Yeah, so then in C you would do that to like y, or 16
So-
equals b to the 2? Because it's, or,
Negative 2.
yeah, negative.
This one was a little more complicated. Alright? So, okay, so, how do I explain this? I don't know if this is going to work very well, but I'm going to do it like this. 1 over b squared is equal to 16. Like that, right? So if I reciprocate it, I get b squared is equal to 1 over 16.
Okay, and then square root of this. Yeah, because I got the answer, but I couldn't really add up that one.
That's kind of how I do that.
Okay.
Okay? So you get a quarter as your answer?
Okay, so always use like the top coordinate.
Yes.
Can you use any of them? Like what if you
Yes.
use 1 and 4? Okay.
could have, yeah. The only one you don't wanna use is 0 and 1. Okay?
Yeah.
Anybody else today?
You just answered my question, so.
Okay. All right, so expect to be done this, again, I'm away Monday, Tuesday, so Thursday I'll be starting 8.1 with you. All right?